Ladies and gentlemen, today we explore one of the most significant Neanderthal discoveries in history, the Altamura Man. The Altamura Man was discovered in 1993 inside Lamalunga Cave, located in the Apulia region of southern Italy, near the town of Altamura. This discovery was not made by professional archaeologists, but by a group of local speleologists, cave explorers, who were investigating the complex network of limestone caves in the area. As they ventured deeper into the cave, they stumbled upon a shocking sight, an ancient human skeleton partially embedded in the rock, covered in thick mineral deposits. The find was so unexpected that it took years for experts to fully understand its significance. Lamalunga Cave itself is a karstic limestone cave, meaning it was formed by the slow erosion of limestone by water over thousands of years. Such environments are known for their stalactites, stalagmites, and other mineral formations, which play a crucial role in the fossilization process. The cave was largely inaccessible, which is likely why the remains had remained untouched for so long. The Altamura Man had been preserved in almost perfect condition, with the minerals forming a calcite crust over the bones, essentially freezing them in time. At first, scientists were unsure whether the skeleton belonged to a Neanderthal or an earlier human species. The calcite incrustation made it difficult to study the bones directly, delaying detailed analysis for many years. It wasn't until later, through the use of modern dating techniques and genetic analysis, that researchers confirmed the remains belonged to a Neanderthal who lived between 128,000 and 187,000 years ago. The discovery of the Altamura Man was particularly significant because most Neanderthal fossils are found as fragmentary remains, a jawbone here, a skull fragment there. In contrast, this was an almost complete skeleton, one of the best preserved examples ever found. Such a discovery provides an unprecedented opportunity to study Neanderthal anatomy in greater detail than ever before. Since its discovery, the site has been the focus of intense scientific interest, with researchers carefully studying the surrounding rock layers and mineral deposits to understand the conditions that led to the Altamura Man's preservation. However, due to the delicate nature of the remains and their fusion with the cave wall, scientists have been unable to extract the full skeleton. Instead, they rely on non-invasive imaging techniques and carefully extracted small samples to study this ancient individual. This discovery remains one of the most important archaeological finds in Europe, shedding light on a time when Neanderthals roamed the continent and offering a rare glimpse into the life and death of an individual who lived thousands of years before modern humans emerged. One of the most intriguing aspects of the Altamura Man is his estimated age, which ranges between 128,000 and 187,000 years old. This makes him one of the oldest known Neanderthal specimens ever discovered. Determining the exact age of such an ancient fossil is a complex process that requires the use of advanced scientific dating techniques. Initially, researchers faced challenges in dating the remains due to their thick calcite incrustation. Unlike many other Neanderthal fossils, which are often found in open sites or buried in loose sediment, the Altamura Man was essentially fused into the cave wall due to the mineral-rich environment. This meant that traditional dating methods, such as radiocarbon dating, which is only effective up to about 50,000 years, were not useful. Instead, scientists turned to more advanced techniques, including uranium-thorium dating. Uranium-thorium dating works by measuring the ratio of uranium and thorium isotopes in the calcite deposits surrounding the bones. Because uranium slowly decays into thorium at a known rate, scientists can estimate when the calcite formed, providing an indirect but reliable age for the remains. By applying this method to the Altamura Man, researchers determined that the mineral deposits covering his bones were at least 128,000 years old, meaning the individual himself must have lived even earlier. Further analysis suggested the remains could be as old as 187,000 years, placing the Altamura Man in the Middle Pleistocene epoch, a critical period in human evolution. This time frame is significant because it falls within a period when Neanderthals were evolving into the distinct species we recognize today. The Altamura Man is thought to belong to an early population of Neanderthals, meaning he might exhibit some features that were intermediate between Homo heidelbergensis, an earlier human ancestor, and later Neanderthals. Studying his bones has helped scientists understand the gradual transition between these species, filling in gaps in the evolutionary timeline. Another crucial aspect of the Altamura Man's age is its implications for Neanderthal DNA research. While most Neanderthal genetic studies have been based on fossils younger than 60,000 years, the Altamura Man's remains are significantly older. This makes them valuable for studying how Neanderthal genes changed over time and how they may have influenced later human populations, including our own species. The discovery of such an ancient Neanderthal also raises fascinating questions about the environment he lived in. During his lifetime, Europe was undergoing climatic fluctuations, with alternating warm and cold periods shaping the landscape and the survival strategies of early humans. The Altamura Man's physical adaptations, such as his robust bones and strong facial structure, suggest that Neanderthals had already developed key survival traits by this time, allowing them to thrive in challenging conditions. By establishing the age of the Altamura Man, scientists have not only gained insight into one individual's place in history, but have also expanded our understanding of Neanderthal evolution, providing a clearer picture of their development, adaptations, and eventual fate. One of the most remarkable aspects of the Altamura Man is the extraordinary state of preservation in which his remains were found. Unlike many other Neanderthal fossils that have been exposed to the elements over time, the Altamura Man was discovered deep within a cave system, where natural geological processes helped protect and fossilize his skeleton for thousands of years. The remains were found inside Lamalunga Cave, a karstic limestone cave in southern Italy. Karst caves are formed by the slow erosion of limestone by acidic water, creating underground chambers, tunnels, and sinkholes. These environments are rich in minerals, particularly calcium carbonate, which plays a crucial role in the preservation of bones. Over time, water flowing through the cave deposited layers of calcite, a crystallized form of calcium carbonate, over the skeleton, encasing it in a hard mineral crust. This process not only protected the bones from decay, but also gave them their distinct fossilized appearance. The Altamura Man's preservation is highly unusual because it is one of the few nearly complete Neanderthal skeletons ever discovered. Most Neanderthal fossils consist of scattered bone fragments, often damaged by environmental conditions or disturbed by later human activity. In contrast, the Altamura Man's bones remained largely undisturbed for tens of thousands of years, locked in place by the calcite formations. One of the most striking features of his preservation is the way the mineral deposits have fused the skeleton to the cave walls. The skull, for example, is covered in a thick layer of calcite, making it appear as though it is emerging from the rock itself. This natural cementing of the bones into the cave structure has posed significant challenges for researchers, as traditional excavation methods cannot be used without risking damage to the fragile remains. Another factor that contributed to the Altamura Man's preservation is the stable climate inside the cave. Unlike fossils found in open-air sites, which are exposed to temperature fluctuations, weathering, and erosion, the cave provided a controlled environment that helped slow the natural decomposition process. The humidity, darkness, and mineral-rich water created the perfect conditions for long-term preservation, ensuring that the skeleton remained intact for well over 100,000 years. However, this exceptional state of preservation also comes with unique challenges. The thick mineral deposits covering the bones make direct analysis difficult, requiring researchers to rely on advanced imaging technologies, such as 3D scanning and CT scans, to study the structure of the skeleton without disturbing it. In 2015, scientists managed to extract a small fragment of the right shoulder blade for genetic and anatomical analysis, confirming that the remains belonged to a Neanderthal and providing insight into his physical characteristics. The preservation of the Altamura Man has not only made him one of the most important Neanderthal finds, but has also provided scientists with an unparalleled opportunity to study the conditions that contribute to long-term fossilization. By understanding how his skeleton survived for so long, researchers can apply this knowledge to the study of other ancient human remains, potentially uncovering new insights into our distant past. The discovery of the Altamura Man is particularly significant because it represents the most complete Neanderthal skeleton ever found. Most Neanderthal fossils consist of isolated bones or fragmentary remains, often scattered and incomplete due to the effects of time, environmental conditions, and human disturbances. In contrast, the Altamura Man is an almost entirely preserved skeleton, offering researchers an extraordinary opportunity to study Neanderthal anatomy in unprecedented detail. When scientists examine Neanderthal fossils, they often have to piece together multiple discoveries from different locations and time periods to reconstruct a full picture of their physical characteristics. However, in the case of the Altamura Man, his entire body is present in one location, embedded within the limestone formations of Lamalunga Cave. This unique preservation allows for a more accurate and direct study of Neanderthal anatomy, providing insights that fragmented remains cannot. One of the most important aspects of this discovery is the near completeness of the skull, which is a crucial part of any hominin study. The skull of the Altamura Man is still fused into the rock, covered in a layer of calcite, but its structure suggests distinct Neanderthal features, including a large brow ridge, elongated cranium, and robust facial bones. These characteristics align with what is known about classic Neanderthal morphology, helping to confirm that the Altamura Man belonged to this ancient human species. Additionally, the presence of an almost intact postcranial skeleton, everything below the skull, provides rare insights into Neanderthal limb proportions, bone density, and overall body structure. Many previous Neanderthal discoveries only included skull fragments or partial limb bones, making it difficult for scientists to fully understand their body shape, movement, and biomechanics. With the Altamura Man, researchers have access to a much broader dataset, allowing them to analyze his arms, legs, torso, and even smaller bones, such as those of the hands and feet. The skeleton's robust bone structure suggests that Neanderthals were well adapted to their environment, with strong muscles, thick bones, and powerful limbs that allowed them to survive in harsh Ice Age conditions. Neanderthals were known for their stocky builds, which helped them retain heat in colder climates, and the Altamura Man's remains provide further evidence supporting this adaptation. Another significant aspect of this discovery is how it helps scientists compare Neanderthals to other human species. By having an almost complete skeleton, researchers can better study how Neanderthals differed from their ancestors, such as Homo heidelbergensis, and how they compare to modern humans, Homo sapiens. The Altamura Man may reveal new clues about Neanderthal posture, locomotion, and overall physical abilities, deepening our understanding of how they lived and interacted with their environment. However, while the Altamura Man is incredibly well preserved, extracting the full skeleton remains a challenge. Since the bones are fused into the rock and covered in thick mineral deposits, removing them without causing damage is extremely difficult. Scientists have to rely on non-invasive techniques such as 3D scanning, CT imaging, and endoscopic cameras to study the skeleton in detail. Despite these challenges, the Altamura Man remains one of the most important Neanderthal fossils ever discovered. His nearly complete skeleton provides a rare and invaluable opportunity to study an ancient human species in ways that were previously impossible. Through continued research and technological advancements, scientists hope to uncover even more details about Neanderthal anatomy, behavior, and evolution, using this remarkable find as a foundation for future discoveries. One of the most groundbreaking aspects of the Altamura Man is the successful extraction of Neanderthal DNA from his remains. Since the fossil is estimated to be between 128,000 and 187,000 years old, this makes it one of the oldest Neanderthal specimens from which DNA has ever been recovered. The ability to extract genetic material from such an ancient individual has provided scientists with invaluable insights into Neanderthal genetics, their evolutionary relationships, and even their interactions with other hominin species. Recovering DNA from ancient fossils is an extremely difficult and delicate process. DNA degrades over time, especially when exposed to factors such as moisture, heat, and microbial activity. Most Neanderthal DNA samples that have been successfully sequenced come from younger fossils, dating back 40,000 to 60,000 years. The fact that the Altamura Man is significantly older makes the successful extraction of his DNA a major scientific achievement. The process of DNA extraction from the Altamura Man was first attempted in 2015 when researchers removed a small fragment of his right scapula shoulder blade for analysis. This was a necessary step because the entire skeleton is fused with calcite deposits, making direct study of the bones extremely challenging. Scientists carefully selected a sample that would cause the least amount of damage, while still allowing for genetic analysis. The extracted DNA was compared with previously sequenced Neanderthal genomes, confirming that the Altamura Man was indeed a Neanderthal. This was an important discovery because, before genetic testing, there was some debate about whether he might have been a member of an earlier hominin species, such as Homo heidelbergensis, an ancestor of Neanderthals. The genetic evidence solidified his classification as a Neanderthal, placing him among the earliest known members of this species. Studying ancient DNA allows researchers to trace evolutionary lineages and determine how different Neanderthal populations were related. The Altamura Man's DNA contributes to this research by providing a genetic link to earlier Neanderthals, helping scientists understand how their genes changed over time. This, in turn, sheds light on the broader story of human evolution, as Neanderthals share a common ancestor with modern humans, Homo sapiens. One of the key questions scientists are investigating is whether the Altamura Man's DNA contains genetic traits that were lost or changed in later Neanderthals. Because he is so old, his genome could reveal earlier versions of Neanderthal genes, some of which might have been passed down to modern humans through interbreeding. Genetic studies have already shown that Neanderthals and Homo sapiens interbred, with many non-African human populations today carrying 1 to 2% Neanderthal DNA. The Altamura Man's genome could help clarify when and how these interactions began. Another exciting aspect of this discovery is how it relates to Neanderthal adaptation and survival. By studying his DNA, scientists can look for genes related to immune function, metabolism, and physical traits, helping to explain how Neanderthals evolved to survive in Ice Age Europe. Some of these genetic traits may have even influenced modern humans, as certain Neanderthal genes linked to immune system function and skin pigmentation are still found in people today. However, extracting and analyzing such ancient DNA comes with significant challenges. Over thousands of years, DNA fragments into tiny, degraded pieces, requiring advanced sequencing techniques to piece it back together. Additionally, contamination from modern human DNA is always a risk, meaning scientists must take extreme precautions during the extraction and sequencing process to ensure the results are accurate. Despite these difficulties, the Altamura Man remains one of the oldest Neanderthal specimens to yield usable DNA, marking an incredible milestone in paleoanthropology. As genetic research techniques continue to improve, scientists hope to extract even more information from his remains, helping to further unravel the mysteries of Neanderthal evolution, adaptation, and their eventual interactions with modern humans. The Altamura Man has provided scientists with a rare opportunity to study Neanderthal anatomy in extraordinary detail. Since his skeleton is one of the most complete Neanderthal remains ever found, researchers can analyze not only his skull, but also his postcranial skeleton, which includes the spine, ribcage, arms, legs, and hands. This level of preservation is highly unusual, as most Neanderthal fossils consist of isolated skull fragments, jawbones, or limb bones. The Altamura Man allows scientists to examine a single, nearly intact individual, offering invaluable insights into Neanderthal physical structure, strength, and evolutionary adaptations. One of the most striking aspects of Neanderthals, including the Altamura Man, is their robust skeletal structure. Unlike modern humans, Homo sapiens, Neanderthals had shorter, stockier bodies that were well-suited to the harsh Ice Age environments of Pleistocene Europe. Their bones were thicker and denser, allowing them to withstand the physical demands of hunting large animals, traveling long distances, and surviving in extreme climates. The Altamura Man's skeleton confirms these traits, as his limb bones are particularly thick and strong, indicating that he was well adapted for a physically demanding lifestyle. The skull of the Altamura Man is another key area of study. Although it remains partially embedded in rock and covered by calcite deposits, scientists have identified several classic Neanderthal features, including a large brow ridge, supraorbital torus, which is one of the defining traits of Neanderthals and is thought to have played a role in facial structure and protection. An elongated cranium with a low, sloping forehead, differing from the more rounded skulls of modern humans. A wide nasal cavity, which may have helped Neanderthals breathe more efficiently in cold, dry environments by warming and humidifying the air before it reached their lungs. A strong jaw and large teeth, which suggests that Neanderthals had powerful bite forces, likely useful for chewing tough meats and plant material. In addition to the skull, the Altamura Man's postcranial bones provide further insight into Neanderthal strength and mobility. His arms and legs are proportionally shorter than those of modern humans, a trait that may have helped Neanderthals conserve body heat in colder climates. This is consistent with Bergman's and Allen's rules, which state that species in colder environments tend to have shorter limbs and stockier bodies to reduce heat loss. One particularly interesting feature of Neanderthals, including the Altamura Man, is their broadened pelvis and rib cage. Unlike modern humans, whose rib cages taper toward the waist, Neanderthals had a wider, barrel-shaped chest, suggesting greater lung capacity. This could indicate a more efficient oxygen intake, which would have been beneficial for endurance-based activities like hunting and traveling long distances across rugged Ice Age landscapes. Another key area of interest is Neanderthal muscle mass and physical strength. Studies of Neanderthal bones have shown that they had thicker attachment points for muscles, suggesting that they were far more muscular than modern humans. The Altamura Man's remains support this idea, as his limb bones are particularly robust, indicating that Neanderthals were likely stronger and more physically resilient than Homo sapiens. Their powerful upper bodies would have been an advantage for close-range hunting, as they often used spears and other handheld weapons to bring down large prey like mammoths, bison, and deer. Despite their strong and stocky build, Neanderthals were still highly mobile and capable hunters. The structure of the Altamura Man's legs and feet suggests that he was well adapted for walking long distances. However, Neanderthals had a slightly different gait than modern humans, due to their shorter lower legs and wider pelvis. Some researchers believe this may have made them slower runners, but more efficient at endurance-based movement, allowing them to track and hunt prey over extended periods. The Altamura Man also provides clues about Neanderthal hands and tool use. Neanderthals were skilled toolmakers, crafting stone tools, weapons, and even fire-starting kits. The preserved hand bones of the Altamura Man suggest that Neanderthals had strong, dexterous hands, with a powerful grip that allowed them to manipulate tools with precision. Their fingers were shorter and broader than those of modern humans, making them well-suited for gripping tools and weapons. By studying the Altamura Man's well-preserved skeleton, scientists continue to uncover new details about Neanderthal biology, strength, movement, and adaptations. His remains provide a crucial piece of the puzzle in understanding how Neanderthals lived, hunted, and thrived in some of the most challenging environments in history. One of the most compelling mysteries surrounding the Altamura Man is the circumstances of his death. Unlike many other Neanderthal fossils that are found in open-air sites, burial locations, or cave shelters used for habitation, the Altamura Man was discovered deep within the remote passages of Lamalunga Cave, a place that would have been extremely difficult to access under normal conditions. This has led researchers to theorize that he may have fallen into the cave by accident, leading to his eventual death. The geography of Lamalunga Cave supports this idea. The cave is part of a karstic limestone system, characterized by deep vertical shafts, sinkholes, and underground tunnels. These formations develop over thousands of years due to the erosion of limestone by water, creating hidden pits and crevices that can be dangerous for unsuspecting animals or even humans who wander too close. It is possible that the Altamura Man, while traveling across the landscape, either fell into one of these hidden openings or attempted to explore a narrow passage and became trapped. Once he fell into the cave, his chances of escape would have been minimal. The walls of the cave are steep, and the entrance he may have fallen through would have been difficult to climb back out of, especially without modern tools or assistance. If he was injured during the fall, perhaps breaking a leg, injuring his spine, or sustaining a head injury, it would have been impossible for him to escape. Another possibility is that he became disoriented in the darkness. Neanderthals, like early Homo sapiens, relied on natural light and fire for visibility. If the Altamura Man entered the cave voluntarily, perhaps in search of shelter, water, or prey, he may have misjudged the terrain, lost his way, and wandered deeper into the cave system until he could no longer find an exit. Without light, even a small misstep could have resulted in a fatal fall into one of the many crevices. If he was alone at the time of the accident, survival would have been unlikely. Neanderthals were highly social beings, living in small, close-knit groups that depended on one another for survival. Injured members of the group were often cared for, as evidenced by fossil remains showing signs of healed fractures, arthritis, and other long-term health conditions that suggest Neanderthals helped each other recover. However, if the Altamura Man was separated from his group, perhaps on a hunting expedition or exploring the area on his own, he would have had no one to rescue him. His cause of death may have been a slow and painful process. If he was trapped but uninjured, he could have survived for days or even weeks, relying on any available sources of water within the cave while slowly succumbing to starvation and dehydration. However, if he suffered a serious injury during the fall, he may have died more quickly from shock, internal bleeding, or infection. Once he died, his body would have remained in the cave, untouched by scavengers due to the isolated nature of the environment. Over time, the mineral-rich water dripping from the cave ceiling would have gradually covered his bones with layers of calcite, preserving them in the remarkable state in which they were discovered thousands of years later. This theory of an accidental fall is currently the leading explanation for how the Altamura Man ended up in the cave, but some researchers continue to explore alternative possibilities. One such hypothesis is that he may have been deliberately placed there by his group in some form of early burial practice, a behavior that has been observed in later Neanderthal sites. However, given the deep and inaccessible location of the remains, this seems less likely than the theory of an unfortunate accident. The exact circumstances of his death remain a mystery, but ongoing research using advanced imaging technology and geological analysis may help uncover more details about his final moments. One of the most remarkable aspects of the Altamura Man is the way his remains have been preserved within the limestone formations of Lamalunga Cave. Unlike most Neanderthal fossils, which are found as fragmented bones exposed to the elements or buried in sediment, the Altamura Man's skeleton became entirely fused into the cave walls, covered by a thick layer of calcite and other mineral deposits over thousands of years. This natural process of preservation has helped keep his bones remarkably intact, providing scientists with a rare and detailed look at Neanderthal anatomy. The preservation process likely began shortly after his death, when his body was left undisturbed in the cave. The cave environment played a crucial role in protecting his remains from scavengers, harsh weather, and other natural forces that typically lead to the decay and destruction of bones. In an open environment, organic matter decomposes quickly, and bones are often scattered by animals or broken down by exposure to wind, rain, and temperature changes. However, in the cool, stable conditions of the cave, his remains remained undisturbed, allowing for a slow but unique mineralization process to take place. Over time, water seeping through the limestone above the cave began to deposit minerals onto the skeleton. These minerals, primarily calcium carbonate calcite, gradually built up, forming a hard, protective coating over the bones. This process, known as speleothem formation, is the same phenomenon responsible for the creation of stalactites and stalagmites in limestone caves. The constant dripping of mineral-rich water led to the slow but steady accumulation of calcite on the Altamura Man's bones, essentially cementing him into the cave walls. This process of calcification has made the Altamura Man one of the best-preserved Neanderthal fossils ever discovered, but it has also presented significant challenges for researchers. Unlike most fossils, which can be carefully excavated and removed from their surroundings, the Altamura Man is entirely embedded within the rock, making extraction extremely difficult without causing damage. Scientists have had to rely on non-invasive techniques, such as 3D scanning, endoscopic cameras, and high-resolution imaging, to study his remains without disturbing their natural state. The mineral incrustation has also helped preserve microscopic details of the skeleton that might have been lost in other environments. For example, researchers can analyze the growth patterns of calcite deposits to estimate how long the preservation process took and gain insights into climatic conditions at the time of the Altamura man's death. By studying the layers of minerals that accumulated over the bones, scientists can learn about changes in temperature, humidity, and rainfall patterns in prehistoric Italy, helping to reconstruct the ancient environment in which Neanderthals lived. Another unique aspect of the preservation is the way the skeleton has remained largely undisturbed for over 100,000 years. In many cases, fossils are found in areas where geological activity, erosion, or human excavation has altered their original positioning. However, the Altamura man remains exactly where he fell, providing scientists with an unaltered glimpse into the past. This rare state of preservation allows researchers to study his original posture and positioning, which could provide clues about his final moments and cause of death. The thick mineral deposits covering the Altamura man have also helped to protect his DNA from complete degradation. Ancient DNA is usually difficult to recover because it breaks down over time due to exposure to oxygen, water, and bacteria. However, the calcite layer may have acted as a natural shield, slowing down the decomposition of organic material. This has made it possible for scientists to extract one of the oldest known Neanderthal DNA samples, providing valuable genetic insights that would not have been possible without this unique form of preservation. Despite these advantages, the calcification process has also created obstacles for further research. Extracting the Altamura man's bones without damaging them remains a major challenge, as the mineral layers have fused the skeleton to the cave walls in a way that makes removal risky and potentially destructive. Some researchers believe that leaving the fossil in place and continuing to study it using advanced imaging technology may be the best approach, while others argue that careful excavation and extraction could provide even more detailed insights. As scientists continue to study the Altamura man, his extraordinary preservation within the cave will remain one of the key factors that make him such an invaluable discovery in the study of Neanderthals and human evolution. Lamalunga Cave, where the Altamura man was discovered, is not just a random location but a site of great geological and paleoanthropological significance. Located in southern Italy, near the town of Altamura, this cave system is part of a broader karst landscape, which has been shaped over hundreds of thousands of years by the slow dissolution of limestone by water. These caves, formed through natural erosion processes, have created a network of tunnels, chambers, and vertical shafts, many of which remain unexplored to this day. The conditions within Lamalunga Cave played a crucial role in the preservation of the Altamura man's remains. The cave provided a stable, cool, and humid environment that helped slow the decomposition process. Unlike fossils found in open landscapes, which are often exposed to wind, rain, and extreme temperature fluctuations, the deep interior of Lamalunga Cave protected the Altamura man's skeleton from environmental damage, allowing for an exceptional level of preservation. The cave's isolated and hard-to-reach nature may also explain why the Altamura man remained undiscovered for so long. The entrance to the cave is small and difficult to access, making it unlikely that later human populations or even animals disturbed the remains. This allowed for over 100,000 years of undisturbed preservation, a rare phenomenon in paleoanthropology. The discovery of the Altamura man in 1993 was a result of modern cave exploration efforts. A team of speleologists, scientists who study caves, was exploring the underground passages of Lamalunga when they stumbled upon an unusual sight, a partially fossilized human skeleton embedded within a limestone wall. At first, the discovery was met with skepticism. It was difficult to determine whether the bones belonged to a prehistoric human, an animal, or even a more recent individual who had fallen into the cave. However, further investigations soon confirmed that the remains were exceptionally ancient. The heavy calcite deposits covering the bones indicated that the individual had been in the cave for tens of thousands of years. As researchers carefully examined the fossilized skull and postcranial remains, they recognized distinctive Neanderthal traits, such as the large brow ridge, elongated skull, and robust bones. These features helped confirm that the Altamura man was not a modern human but a member of the Neanderthal species. Since its discovery, Lamalunga Cave has become a key site for Neanderthal research, drawing scientists from around the world. Unlike other Neanderthal fossil sites, which often contain scattered bones from multiple individuals, the Altamura Man represents a nearly complete skeleton in its original position, offering a rare opportunity to study an ancient human ancestor in a natural burial-like context. The cave's geological composition has also provided insights into the environment of prehistoric Italy. By analyzing the stalactites, stalagmites, and mineral deposits within the cave, scientists can reconstruct past climate conditions and better understand the ecosystem in which Neanderthals lived. Lamalunga Cave's mineral layers contain traces of ancient rainfall patterns, temperature fluctuations, and even atmospheric conditions, helping researchers piece together the broader environmental history of the region. Another intriguing question that scientists continue to explore is whether Lamalunga Cave was ever used by other Neanderthals or early humans. So far, no direct evidence of habitation such as stone tools, fire pits, or butchered animal bones has been found near the Altamura Man's remains. This suggests that the cave may not have been a regular living site for Neanderthals, but rather a hazardous area that was accidentally entered, possibly leading to fatal consequences. The continued study of Lamalunga Cave and its unique preservation conditions offers exciting possibilities for further discoveries. Scientists hope that with improved imaging technology and careful excavation, they may uncover additional fossils, artifacts, or environmental clues that could provide even deeper insights into Neanderthal life and evolution. One of the most groundbreaking aspects of the Altamura Man discovery is the ability to extract and analyze ancient Neanderthal DNA from his remarkably well-preserved remains. Unlike many other Neanderthal fossils, which have been exposed to the elements or degraded over time, the Altamura Man's skeleton remained protected within the cave, encased in a mineral shell that helped slow down the decay of genetic material. This has provided scientists with a rare opportunity to study one of the oldest known Neanderthal DNA samples, potentially revealing crucial insights into Neanderthal evolution, biology, and their relationship with modern humans. The extraction of ancient DNA from fossils is an extremely delicate and complex process. Over thousands of years, DNA naturally degrades due to exposure to oxygen, bacteria, temperature changes, and other environmental factors. In most cases, ancient DNA fragments are highly damaged and contaminated, making it difficult to obtain reliable genetic sequences. However, because the Altamura Man's remains were sealed within a stable, mineral-rich cave environment, his DNA was somewhat protected from these destructive processes. In 2016, scientists successfully extracted mitochondrial DNA, mtDNA, from the Altamura Man's remains. Mitochondrial DNA is inherited only from the mother and tends to be more abundant and better preserved than nuclear DNA, making it a valuable tool for studying ancient populations. By analyzing his mtDNA, researchers were able to confirm that he was a Neanderthal, fitting within the broader genetic diversity of Neanderthal populations that lived across Europe and Asia. One of the most significant findings from the Altamura Man's DNA analysis was his genetic age. Scientists determined that his genetic material was between 128,000 and 187,000 years old, making it among the oldest Neanderthal DNA samples ever sequenced. This places him in the Middle Pleistocene period, a crucial time in Neanderthal evolution when they were adapting to Ice Age environments and developing the physical traits that distinguish them from both earlier hominins and modern humans. By comparing his DNA to other known Neanderthal genomes, researchers have gained insights into the genetic diversity of Neanderthals across different regions and time periods. The Altamura Man's DNA suggests that Neanderthals were not a static species, but had significant genetic variation, influenced by environmental pressures, migrations, and population changes over tens of thousands of years. One of the key areas of interest in Neanderthal DNA research is their relationship with modern humans, Homo sapiens. Studies have shown that all non-African humans today carry between 1 to 2% Neanderthal DNA, indicating that there was interbreeding between Neanderthals and early modern humans when their populations overlapped. While the Altamura Man lived long before this period of contact, Since Homo sapiens had not yet migrated into Europe at the time of his existence, his DNA helps establish a genetic baseline for earlier Neanderthal populations. This allows scientists to trace how Neanderthals evolved and how their genes were later passed on to modern humans through interbreeding events. Another important aspect of DNA research is understanding Neanderthal adaptations and survival strategies. By examining the Altamura man's genetic makeup, scientists can identify genes related to immune function, metabolism, and physical traits that helped Neanderthals survive in harsh Ice Age environments. For example, previous studies on Neanderthal DNA have identified genetic variations linked to cold adaptation, muscle strength, and skin pigmentation, all of which were crucial for life in prehistoric Europe. The Altamura man's DNA may provide further evidence of these adaptations and show how they developed over time. Despite the success in extracting mitochondrial DNA, sequencing the nuclear DNA, which contains the majority of genetic information, from the Altamura man remains a challenge. Nuclear DNA is much harder to preserve, and contamination from modern sources, such as human handlers or environmental microbes, can interfere with accurate sequencing. However, with advancements in genetic technology, researchers hope to recover more complete genomic data from his remains in the future. The study of the Altamura man's DNA is far from complete, and future research could reveal even more about Neanderthal genetics, their evolutionary history, and their biological connections to modern humans. As techniques for DNA extraction, sequencing, and analysis continue to improve, scientists are optimistic that the Altamura man will remain a key figure in our understanding of human ancestry and evolution. The discovery of Altamura man provides an incredible opportunity to gain insights into Neanderthal life and behavior, offering a glimpse into how these ancient humans lived, survived, and interacted with their environment. Although much of what we know about Neanderthals comes from various fossil sites across Europe and Asia, the uniquely preserved state of the Altamura man's remains allows scientists to examine his anatomy in extraordinary detail, helping to reconstruct his physical characteristics, lifestyle, and possible role within his community. Physical characteristics and adaptations. Like other Neanderthals, the Altamura man exhibited a robust and heavily built frame, suited for enduring the harsh climates of the Ice Age. His skull features a large brow ridge, elongated cranium, and prominent midface, all of which are distinct Neanderthal traits. His bones, particularly in the arms and legs, suggest strong musculature and a stocky build, which would have been beneficial for traversing rocky landscapes, hunting large game, and enduring cold environments. One of the key questions researchers hope to answer is whether the Altamura man suffered from any physical ailments or injuries during his lifetime. Many other Neanderthal fossils show signs of healed fractures, arthritis, and degenerative diseases, indicating that their harsh lifestyle often led to significant physical strain. Since Neanderthals were heavily reliant on close-range hunting techniques, such as using spears to ambush large animals like mammoths, bison, and deer, they frequently sustained injuries. If the Altamura man's skeleton shows similar evidence of trauma, it could provide further confirmation of the physically demanding nature of Neanderthal life. Additionally, the Altamura man's teeth and jaw structure may offer clues about his diet and eating habits. Neanderthals primarily consumed large herbivores, but evidence from other sites suggests that their diet was more varied than previously believed, including plants, nuts, berries, and even cooked foods. By analyzing microscopic wear patterns on his teeth and conducting isotopic analysis, scientists can determine what kinds of food he regularly consumed, giving insight into the dietary adaptations of Neanderthals living in prehistoric Italy. Social behavior and group dynamics. One of the most fascinating aspects of Neanderthal research is their social structure and group behavior. Evidence from various Neanderthal sites suggests that they lived in small, close-knit groups, often consisting of extended family members. These groups were highly cooperative, working together to hunt, gather food, care for the sick and injured, and possibly even perform rudimentary cultural practices. If the Altamura man was part of a larger Neanderthal group, he likely relied on his community for survival. Neanderthals are believed to have engaged in altruistic behavior, meaning they took care of individuals who were injured or unable to hunt for themselves. Some Neanderthal fossils show signs of long-healed injuries, meaning their groups nursed them back to health rather than abandoning them. If the Altamura man had suffered an injury earlier in life, the condition of his bones could reveal whether he received care from his group. Additionally, Neanderthals are thought to have had a complex emotional and cognitive world, capable of forming strong social bonds and possibly even expressing symbolic behavior. While no direct evidence of burial rituals has been found in Lamalunga Cave, other Neanderthal sites have revealed signs of intentional burials, where bodies were placed in specific positions, sometimes with stone tools or animal bones nearby. If further research suggests that the Altamura man was placed in the cave intentionally, rather than accidentally falling in, it could provide further evidence of ritualistic behavior or even an early understanding of death. Tool use and intelligence. Neanderthals were not primitive or unintelligent. Rather, they were skilled toolmakers and problem solvers who thrived in harsh Ice Age environments. The Mysterian tool culture, associated with Neanderthals, included finely crafted stone tools, wooden spears, and even evidence of fire use. These tools allowed them to process food, hunt effectively, and defend themselves against predators. Although no stone tools were found directly alongside the Altamura man's remains, his discovery in Italy places him in an area where other Neanderthal tools have been uncovered. This suggests that he and his group were likely proficient in toolmaking, using hand axes, scrapers, and spears to hunt animals and prepare food. Additionally, Neanderthals are believed to have used fire for cooking, warmth, and protection, meaning the Altamura man may have been part of a group that regularly utilized fire as a survival tool. There is also growing evidence that Neanderthals may have possessed rudimentary language skills. The discovery of the hyoid bone, a small bone in the throat associated with speech, in other Neanderthal fossils, along with genetic studies of the FOXP2 gene, linked to language abilities in modern humans, suggests that Neanderthals were capable of some form of verbal communication. While it is impossible to know exactly how they spoke or what their language sounded like, the Altamura man may have communicated with his group through vocalizations, gestures, or a form of early language. Daily life and survival strategies. The Altamura man likely spent his days engaged in the core activities essential for Neanderthal survival. Hunting and foraging. Neanderthals primarily hunted large Ice Age mammals, requiring strong cooperation and tactical planning. If the Altamura man was a skilled hunter, he may have participated in these group efforts, tracking and ambushing prey using handmade spears and stone tools. Shelter and territory. While caves provided natural shelter, Neanderthals also lived in open-air camps where they built temporary dwellings using wood and animal hides. It is unclear whether Altamura man's group used Lamalunga Cave as a shelter or whether he ended up there by accident. Crafting and tool use. Neanderthals shaped tools from flint, bone, and wood, making weapons for hunting and scrapers for processing animal hides. These tools were essential for clothing, fire starting, and food preparation. Social interactions and learning. Neanderthal children were likely taught survival skills at an early age, learning from older members of the group. If the Altamura man lived to adulthood, he would have passed on knowledge and techniques to younger generations, ensuring the survival of his community. While the Altamura man's exact role within his group remains unknown, his strong physical build, potential hunting abilities, and social connections suggest that he was part of a tight-knit Neanderthal society that depended on cooperation for survival. The study of his fossilized remains, combined with ongoing research into Neanderthal culture, tool use, and genetics, continues to shape our understanding of how Neanderthals lived and thrived for thousands of years. The discovery of Altamura Man in 1993 marked a significant milestone in the study of Neanderthals, but even decades later, his remains continue to be a subject of intense scientific investigation. Each year, advancements in technology, genetics, and archaeological methods provide new insights into his life, environment, and species. Researchers from multiple disciplines, including paleoanthropology, archaeology, genetics, and geology, are working together to uncover more details about Altamura man's history and the world he inhabited. Challenges in studying Altamura man. One of the primary challenges in researching Altamura Man is his location within Lamalunga Cave. Unlike many other Neanderthal fossils that have been excavated and transported to laboratories, Altamura Man's skeleton remains embedded within thick layers of calcite deposits, making it extremely difficult to extract without causing damage. The mineral incrustation that preserved him for over 128,000 to 187,000 years now also makes it challenging to fully analyze his remains. Scientists must use non-invasive techniques such as 3D scanning, high-resolution imaging, and endoscopic cameras to study his bones without removing them from the cave. Additionally, the cave environment presents logistical difficulties. The deep, narrow passages of Lamalunga Cave make it difficult for researchers to access the fossil for detailed analysis. This has slowed the pace of study, as only small teams of specialists can enter the site, and every movement must be carefully planned to avoid disturbing the fragile structure of the cave. New technologies in paleoanthropology. Despite these challenges, cutting-edge scientific techniques are allowing researchers to study Altamura Man in ways that were impossible in the past. Advanced 3D scanning technology has enabled scientists to create precise digital reconstructions of his skull and bones, allowing researchers worldwide to examine his features without needing to physically remove the remains. These 3D models can be used to study his anatomy, reconstruct his face, and compare him with other Neanderthal specimens. One of the most exciting areas of ongoing research is ancient DNA analysis. In 2016, scientists successfully extracted mitochondrial DNA from Altamura Man, confirming that he was a Neanderthal. However, obtaining nuclear DNA, which contains the majority of genetic information, remains a difficult task due to the mineralization of his bones. New advancements in DNA extraction techniques and computational genomics may soon allow researchers to retrieve more genetic material, providing deeper insights into his ancestry, health, and potential genetic connections to modern humans. Another crucial area of study is isotopic analysis, which examines the chemical composition of his bones to determine his diet, migration patterns, and environmental conditions. By analyzing the ratios of certain elements in his skeletal remains, scientists can learn what types of food he ate, whether he lived in a stable environment or moved between regions, and how he adapted to climate changes. What Altamura Man can teach us about Neanderthals. The continued study of Altamura Man has broader implications for our understanding of Neanderthals as a species. His fossilized remains offer a rare glimpse into the life of a Neanderthal from an early period, helping scientists answer critical questions such as, how did Neanderthals adapt to different climates and landscapes? What was the typical lifespan of a Neanderthal, and what diseases or injuries did they commonly suffer from? Did Neanderthals engage in symbolic behavior or early forms of cultural expression? How genetically diverse were Neanderthal populations across Europe? By comparing Altamura Man's features with those of other Neanderthal fossils found in different regions and time periods, researchers can map out how Neanderthals evolved over thousands of years. His age, estimated to be between 128,000 and 187,000 years old, places him in a crucial period of Neanderthal development, when their population was adapting to changing Ice Age environments and refining their survival strategies. Future excavation plans and scientific goals. There is ongoing debate within the scientific community about whether Altamura Man should be fully excavated from the cave for more detailed analysis. Some researchers argue that removing the fossilized remains would allow for better study and preservation, while others believe that the risks of damaging the skeleton are too high. If excavation eventually takes place, it will require cutting-edge conservation techniques to ensure that the bones remain intact and that any extracted material is carefully preserved for further research. Additionally, scientists are exploring the possibility of discovering more Neanderthal fossils within Lamalunga Cave. Since caves often served as temporary shelters or natural traps, it is possible that other ancient human remains, tools, or artifacts may be hidden within unexplored chambers. Future cave exploration, combined with ground-penetrating radar and archaeological surveys, could lead to new discoveries that shed even more light on the lives of Neanderthals in prehistoric Italy. The study of Altamura Man is far from complete, and each new technological breakthrough brings us closer to understanding who he was, how he lived, and what his existence means for the broader story of human evolution.